Right now, at this hour, in beehives across your region, a shift change is happening that most beekeepers will never observe. The daytime guard cohort has been replaced by a nighttime cohort with a measurably different olfactory sensitivity profile, calibrated to the specific chemical signatures of the predators that come after dark. Ventilator bees are positioned near the bottom board, fanning in coordinated bursts, holding the brood nest at 93 degrees while the air outside the box is 20 degrees colder. And somewhere in the dark interior of the hive, a small subset of workers is moving through the frames on a task that has no daytime equivalent, and that most people who keep bees have never thought to look for. Most people assume a hive at night is a scaled-down version of a hive during the day. Fewer bees, active, lower energy, a holding pattern until dawn. But the reality is far more structured, far more specialized, and far more active than that. The colony at 2 a.m. isn't resting. It has reorganized. Here is what reorganized looks like. A ventilation system running on a 2-degree tolerance. A guard rotation with peak sensory acuity between 1 and 4 a.m. An undertaker cohort removing 8 to 10 corpses per hour from the frames. And at the center of the colony, the queen, in the closest thing to sleep she ever experiences, held in position by workers who know, by some mechanism that isn't fully understood, that this is the hour she needs the most. Welcome back to Bee Mind. Subscribe before you go. What you're about to understand happens every night in your hive, and it will change what you think you know about the box in your garden after dark. The third section covers the undertaker caste, one of the colony's most critical systems, running entirely after dark. And the last one changes what the hive means at 2 a.m. Number 1, the nighttime ventilation system, and the bees running it at 2 a.m. while the rest of the colony sleeps. Most people assume hive temperature is a passive outcome. The colony generates heat, the wooden walls hold some of it, and the night air takes the rest. The box is insulated or it isn't, and the bees manage accordingly. Temperature regulation in this model is something that happens to the hive rather than something the hive does. It isn't passive. It has never been passive. Research from the University of Würzburg and the foundational work of Jürgen Tautz on honeybee colonies as superorganisms established what active nighttime thermoregulation actually looks like in measurable terms. A healthy colony maintains brood nest temperature between 93 and 96 degrees Fahrenheit, continuously, not approximately, not on average, but within that 2-degree band through conditions that would require substantial mechanical intervention to replicate in any engineered system. The bees that make this possible are ventilator bees, a subset of workers that position themselves at specific locations in the hive, primarily near the entrance and along the inner walls adjacent to the brood frames, and fan their wings in coordinated bursts that create directional airflow through the colony interior. They don't fan randomly. The bursts are timed, the positions are specific, and the airflow they produce moves in a consistent direction through the brood nest. Thermocouple studies measuring internal hive temperature at 15-minute intervals through the night documented the precision of this directly. External temperatures dropping 20 degrees between midnight and 4 a.m. produced internal brood nest variance of less than 2 degrees Fahrenheit. The ventilation system absorbed the change. The bees running it worked harder as the night got colder and eased back as it warmed toward dawn, adjusting in real time to conditions they were detecting through the same chemoreceptors they use for everything else. Your hive at 2 a.m., a dark box, silent entrance. Nothing visible from the outside, nothing that suggests anything beyond stillness. Inside, near the bottom board, a row of bees with their wings moving in synchronized bursts. Not random, not restless, but deliberate, positioned, running a mechanical operation that has been continuous since the colony formed and will be continuous until it ends. They are not the bees you see in the morning. They will not be at the entrance when you walk out after breakfast. They are the night shift, and they run without observation or acknowledgement every night of the colony's life. What this tells you about your hive is this: the stillness you see from outside at 2 a.m. is not the colony's reality. It is a surface. Underneath it, the machinery is running, but temperature isn't the only thing the colony is managing in the dark. What comes next happens every night, and most beekeepers have never seen it. Number 2. The night guard rotation, and how the hive manages its own security between midnight and dawn. Most people assume the hive's security system scales down at night. Fewer bees at the entrance, a reduced target, the darkness itself providing cover. The daytime guards go in, the entrance narrows, and the colony relies on the same bees in a quieter configuration. That's the working model. It's wrong about almost everything except the narrowed entrance. The guard system doesn't scale down at night, it restructures. Research from the Laboratory of Insect Neurophysiology and Pharmacology at the University of Toulouse, and work published in PLOS I on honeybee chronobiology, documented the nighttime guard cohort as a functionally distinct group from its daytime equivalent. Daytime guards are typically older foragers pulling secondary duty between foraging trips, bees whose primary identity is not guarding, but who rotate through the role as colony demand requires. The nighttime cohort is different in ways that are measurable at the neurological level. These are younger bees with olfactory sensitivity profiles specifically calibrated to the chemical signatures associated with the colony's primary nocturnal threats: wax moths, small hive beetles, and skunks, each of which has a distinct chemical approach signature that differs from the daytime threat profile. Antenna sensitivity in nighttime guard bees peaks between 1 and 4 a.m., in direct alignment with the primary activity window of the threats they're calibrated to detect. A guard bee at 3 a.m. is running a more sensitive chemical detection system than the same bee would run at noon. She is not the same bee at noon, functionally. She is something the colony built for this specific hour. The entrance of your hive at 3 a.m. reduced to a narrow gap by the bodies of the bees pressed against the opening from inside. 2 or 3 bees visible at the edge, not clustered inward for warmth, but facing outward, antennae working the night air in slow, continuous arcs. They are not drowsy. They are not waiting for morning. They are, by every measurable neurological standard, more alert than at any point during the afternoon. What this tells you about your hive is this: the colony doesn't sleep the way you sleep. A single state, uniform, all systems quieted. It shifts. Different bees take different roles. The sensory systems that matter most in the dark are the ones running at peak capacity precisely because it is dark. The hive is not less defended at 3 a.m. In some ways, it is more defended than at any other hour. And then there are the bees working deeper inside at 2 a.m., the ones running an operation that most beekeepers have never seen and most people never think about. Number 3, the undertaker bees and the nightly removal operation that keeps the colony alive. Most people assume dead bees are cleared from the hive opportunistically. A worker encounters a corpse, removes it, goes back to whatever she was doing. An incidental task, handled as needed. Nothing systematic about it. The reality is that undertaking is one of the most specialized roles in the colony, performed by a consistent and self-selected cohort of workers, active primarily at night, running a disposal protocol that is one of the colony's primary disease prevention systems. The research establishing this came from the laboratory of Gene Robinson at the University of Illinois, with supporting work published in behavioral ecology and sociobiology. Undertaker bees represent roughly 1 to 2% of the colony's workforce at any given time. They are not assigned this role. They self-select into it based on a specific gene expression profile associated with enhanced olfactory sensitivity to oleic acid. The primary fatty acid compound released by bee corpses as they begin to decompose, the chemical signal that marks a bee as dead rather than alive or simply still. Bees with higher sensitivity to oleic acid are more likely to detect and respond to corpses, and more likely to establish the undertaker behavioral pattern. It is, in practical terms, a vocation built on a sensory gift. Undertakers work primarily between dusk and 4 a.m. They locate corpses on the frames through chemical detection, carry them toward the entrance, and deposit them outside the hive, a trip most of them make repeatedly through the night. In a healthy colony, this runs at a rate of 8 to 10 corpse removals per hour. What happens when it stops is documented and measurable. A colony that loses its undertaker cohort through targeted pesticide exposure, disease, or the kind of population collapse that disproportionately affects specialist castes, shows measurable increases in pathogen load within 72 hours. The corpses left on the frames become primary vectors for nosema, American foul brood, and secondary fungal infections. The hive's disease burden correlates almost directly with the efficiency of its undertaker system. The cleanliness of the hive is not ambient, it is maintained. The bottom board of your hive at first light, and just outside the entrance in the grass, a small scattering of dead bees, 4, 6, sometimes a dozen, placed there in the dark by bees you have never seen making the trip. You have walked past this evidence every morning. You may have assumed the bees simply fell out, or were pushed out casually, or died at the entrance on their way somewhere else. They were carried, one at a time, through the dark by a caste of workers whose entire purpose is to ensure that what dies inside the hive does not stay inside the hive. What this tells you about your hive is this: the cleanliness of a healthy colony is not incidental. It is managed every night by bees whose whole role is sanitation. And the health of your colony depends on them in ways that aren't visible until they're gone. Number 4 changes what you think about the colony's internal clock and who exactly is keeping it. Number 4, the colony's internal clock and the bees whose entire job is to know what time it is. Most people assume a colony's daily rhythms follow the light. The sun rises, the foragers respond, the sun sets. The colony winds down. Light is the input, behavior is the output, and the relationship between them is direct and simple. Light matters. But the colony's timekeeping system runs underneath light, independent of it, sustained through the dark hours by a specific subset of workers whose role has no equivalent in any other social insect studied so far. Research from the Bloch Lab at Hebrew University of Jerusalem, published in the Proceedings of the National Academy of Sciences, identified what the field now calls timekeeper bees, a worker cohort distinguished not by physical morphology, but by the phase at which they express the core circadian clock genes, period, and timeless. In most bees, these genes cycle in a rhythm aligned with daylight. In timekeeper bees, the cycle runs offset from the rest of the colony. They are active and chemically broadcasting during the 2 to 4 a.m. window specifically, maintaining vibrational and chemical signals that entrain the circadian rhythms of the bees around them. They are not keeping their own time. They are keeping the colony's time. Remove the timekeeper cohort from a colony in controlled conditions, and the result is measurable and fast. Within 48 hours, the colony's collective circadian rhythm begins to degrade. Foragers leave at the wrong times. Guard rotations desynchronize. Brood care timing drifts. Nurses appear at the frames outside the optimal feeding window, and larvae receive care on a schedule that doesn't match their developmental needs. The colony doesn't collapse immediately. It becomes mistimed, and a mistimed colony is a colony running at reduced efficiency in every system simultaneously. Your hive at 3 a.m., the cluster quiet, most bees still, the ventilators working near the bottom board, the guards at the entrance, and moving through the frames in the dark. not foraging, not guarding, not removing anything. A small group of workers whose purpose is invisible from the outside and whose absence would be felt by every other bee in the box within 2 days. They are holding time in place, quietly, in the dark, while the colony they serve sleeps around them. What this tells you about your hive is this: a colony doesn't just live in time the way you live in time, moving through it, subject to it. It maintains time from the inside, using bees whose whole purpose is to make sure the rest of the colony knows when they are. I've saved this one for last because it is the thing that happens in the deepest part of the night, and the thing that changes what the box in your garden means to you after dark. In 2023, research published in PLOS ONE using miniaturized accelerometer tags attached to individually marked queens documented something the field hadn't confirmed before. Honeybee queens have a rest phase, a genuine, measurable, behaviorally distinct rest phase, typically occurring between 1 and 4 a.m., during which the queen's locomotor activity drops by more than 90%. Her antennal movement slows, and she holds a fixed position on the comb. Worker bees actively maintain a specific formation around her during this window, a configuration that differs from their daytime clustering behavior in ways that suggest the workers know, by some mechanism not yet fully understood, that this period is different, disrupting the queen's rest phase through high vibration, inspection, or temperature fluctuation in that window, correlated with measurable reductions in laying rate in the 48 hours following. She needs this. The colony protects it. This is the closest thing to sleep that has been confirmed in a queen bee. And it happens between 1 and 4 a.m., in the dark, in the center of your hive, while everything else we've talked about runs around her. Think about the last time you stood near your hive after dark. Maybe you went out to check on it. Red light torch, just for a minute, just to listen. The low hum of the cluster, the entrance quiet, the garden still around you, everything about the hive suggesting it had gone somewhere you couldn't follow. It hadn't gone anywhere. It was doing all of this. The ventilators near the bottom board, holding 2 degrees of tolerance through the coldest hours. The night guards at the entrance, antennae running at peak sensitivity. The undertakers working the frames, carrying the dead out one at a time into the dark. The timekeepers moving through the colony, holding the rhythm that every other bee depends on. And at the center, the queen, still, held in place by workers who arrange themselves around her at 1 a.m. and will hold that arrangement until 4. The hive at 2 a.m. is not a metaphor for something. It is a place, a specific, operational, fully running place in your garden, doing things that have no equivalent in any human organization, coordinated without a coordinator, maintained without maintenance, running systems that most of the bees participating in them don't know they're participating in. You don't need to go out at 2 a.m. You don't need to disturb the rest phase or interrupt the undertakers or redirect the timekeepers. You just need to know it's happening. The hive you walk past every morning is the evidence of a night you didn't witness. Now you know what that night contained. The beekeepers who think about their hives after dark, who wonder without quite knowing why they're wondering what's happening in there at 2 a.m. They weren't wrong to wonder. The hive at 2 a.m. is doing more than the hive at 2 p.m. in ways that are now measurable and documented. Their instinct that the night mattered was correct. They just didn't have the specifics yet. Now they do. Go back to where we started. The garden at 2 a.m., the house dark, the hive in the corner, silent box, still entrance, nothing visible from where you're standing. You know now what silent means in that context. The ventilators running, the guards alert, antennae working the night air, the undertakers on their rounds, the timekeepers holding the rhythm in the dark, and at the center, the queen at rest, surrounded by workers who know this is the hour she needs them. The box in your garden has never been empty at 2 a.m. It has always been this full. Now you know what it's full of. Tonight, if you have a hive, go out after dark. Not to inspect, just to stand near it for 60 seconds. Put your ear against the wood. Listen for the low, continuous hum of the ventilators. Look at the entrance. You now know what's happening just inside that gap. It's worth knowing from the outside. Tell me in the comments, have you ever gone out to your hive after dark? And what did it feel like to stand next to it at night? And did you notice anything at the entrance, any sound or movement that you couldn't explain at the time? If this reached someone who keeps bees or who thinks about their hive at night without knowing exactly why, send it to them. I read every comment. I'll see you in the next one.